right, so today we're going to talk about the ideal gas law. You just got done talking about using the combined gas law to kind of figure out what you're solving for with Mrs. Copeland and Mr. Thompson. So the ideal gas law is going to be PV equals nRT.
Pervnert.
I just love saying this equation. PV equals nRT. It just...
Pervnert. That's
Say it,
pervnert,
Saw.
not pervert. There's no E. Okay.
All right, so first of all, we want to show you where this equation is located because this is one of those things that's in your reference materials that you were given at the beginning of the school year. And depending on where it's, which kind of reference materials you were given, in my room it's the blue laminated papers.
Yeah, they're either, no, this one isn't on the back of your periodic table, but it's on the other page that you were given at some point in time. And we'll probably get another one because you lose everything. And so you will notice that this one right here is that same equation, PV equals nRT.
And honestly, you should be familiar with all of those variables except for one.
Okay, you'll also notice on here that you have all your other equations for the similar stuff on here as well. So you can look at any of those. But yeah, you should know all of this stuff. We said pressure is...
Oh, well, pressure is P.
Right? That makes sense. V is...
For volume. N
is
moles.
number of moles.
Oh,
that's where the N comes from.
Oh,
it's not M, right? And T is...
Temperature.
Which is always in...
Temperature is always in Kelvin for gas laws.
Kelvins. Okay, so the R is probably the one that y'all don't actually know. And it is what we call the ideal gas constant. What does it mean to have a constant?
I know that the sun constantly rises in the east and sets in the west, so does that mean it happens every day, all the time like that?
Every time. It doesn't change, right?
Mm-hmm.
So if you have your reference chart, on the other side of the one that had the formula, we have all of our constants, and here is your R.
So when I'm looking at the R, I notice I've got 3 different values, and they all look the same, except for, well, I say they all look the same because it's different numbers, but the difference between all of them within their units is they all have a different unit for pressure.
Mm-hmm.
And since Mr. Thompson and Mrs. Copeland had already talked about this with you, that if you're probably not familiar with a unit, it's probably a pressure unit.
Mm-hmm.
And we'll have several different units for pressure. We'll have several different values that we can use for our R value.
Yeah, so it's not the whole thing. You have to pick one of the 3 that you're using. And so if you're using atmospheres, you'd use the first R value. If you're using kPa, kilopascals, you're using the second one. And this would be for millimeters of mercury, mmHg. Okay, so it all depends on what you're using. Okay, so here's our example. How many moles of oxygen will occupy a volume of 2.5 liters at 1.2 atmospheres and 25 degrees Celsius? So when we go through a problem,
we should approach this like we've been doing stoichiometry, right?
Same thing, yeah. We're gonna pull everything out of our equation that we're being given, okay? And so we can figure out what we want.
Okay.
So it says how many moles.
So I already know what I want. It's
Right.
number of moles. So what I'm looking for is N.
N. So there's my question mark.
Okay, and then they give me 2.5 L.
Okay, so what is L?
L is for liters.
Liters.
And here's another important thing. When we're doing our calculations for this for PV equals nRT, your volume must be in liters.
Mm-hmm. You can't do milliliters with this one. And this one's pretty clear, though. It says occupy a volume of. But if it didn't tell you that was a volume, you should know because it's liters, and liters is volume, right?
Mm-hmm. And then it says at 1.2 ATM.
Okay, that might be one that y'all aren't as familiar with.
Does that mean something to do with money?
Wouldn't that be nice? Atmospheres.
Oh.
Atmospheres are
Pressure.
So whenever it's a weird one, that's probably what it is.
And then 25 degrees Celsius. Ah, dang it.
obviously that's a temperature, right? We know 25 degrees Celsius is a temperature.
And we should be familiar with the fact that the work that you just got done with, the temperature cannot be in Celsius. So anytime you see Celsius, you need to automatically think about, how do I change it to Kelvin?
Which is pretty straightforward. And actually, that one is in your constant as well. On your constant chart, there's a spot that tells you that
How to
convert it. But we should know, because it's pretty simple.
We're going to do 25 plus 273. And when I do that, I get 298 degrees Kelvin.
It's actually just kelvins.
Oh, Kelvin, my bad.
And so I have all this information, right?
Mm-hmm.
So I only have one of everything. So that tells me I'm going to be using the ideal gas law.
Okay.
Okay. That's a good indicator between using the ideal gas law versus the
combined everything.
gas law, is that one you would have two of things because you're changing, and this one there's just one of everything. So my formula is PV equals nRT. So what letter am I missing?
You're missing R, and
R.
What we talked about in the past with anything that had a constant, like way back when we talked about waves.
Mm-hmm. That's a long time ago.
Yeah, long time ago, first 6 weeks. Or second 6 weeks.
Second 6 weeks is still a long time.
You don't have to be given constants. It's something that you can look up. So you're never going to be given the R value for these. You're going to look it up. So now, again, one of the things that we really need to stress to you is that it must match your pressure unit. So we need to look at our pressure units.
Yeah, so we know our pressure is in ATM. So if we go over to our chart, the one that's ATM is the 0.0821.
Okay.
So I have 0.0821 or 0.0821, same thing. And I'm not even going to write the units. They are a pain in the butt. I'm just not going to write them for this. Okay? So we know that's our constant.
All right, so let's start plugging in. We've got P, which is 1.2.
1.2
times
V
2.5
2.5
is equal to
an unknown N. So I'm going to put my letter.
Okay, and then times R, which we said was 0.0821. And then times our degrees, or temperature, which is in Kelvin, so it's going to be 298.
Okay, so 1.2 times 2.5
is, so we're going to just condense this so we have nice single-digit numbers to work with, so we're simplifying our math.
Yes.
All right, then we're going to go to the other side, and we need to do 0.0821 times 298, which is going to give us 24.47 if we round to 2 decimal places.
Mm-hmm. Okay, so from here we're just going to do your basic algebra, rearranging the equation for the unknown. So if I'm multiplying by 24.47, I need to do the opposite to get rid of it. So I'm going to divide by it. Okay, what I do to one side, I have to do to the other. So it's 3 divided by 24.7.
And when I pull up my handy-dandy calculator, I get
0.12.
And since this is in, my units are moles.
And that is my N. Okay,
right.
There you go.
So really all you have to do on this is just kind of plug and chug. Plug your numbers in and let's chug out some math!
Just some basic algebra, guys. It's not anything complex. I know that scares some of you guys, and some of you guys are like, yeah, math, I can do that.
I love math. That's my favorite.
This is not that bad. Okay. So now we're going to do some guided practice with you. Real quick.
So if you understand this, you might want to pause it, try to take a stab at it on your own. Otherwise, if you feel like you need a little bit more help, stay with us.
Okay. So, again, I'm going to go through. I'm just going to pull all my stuff out.
Okay.
So it says, what volume? All right.
So automatically we know we're looking for volume.
Okay. 2 moles.
That was easy. N is moles.
N is moles. 2. Okay. Of nitrogen occupy at 720 mmHg. There's another one of those weird units, right? So that's going to be
That doesn't have to do with fighting, mmHg. Millimeters of mercury, that's what it's for.
Do we need to explain that one? Should we?
Nah. You get it, you get it.
It's
Okay.
literally how much mercury is in a tube. That's literally what that's off of. Sorry, I just had to. Okay.
All right, and then 25 or 20 degrees Celsius.
20 degrees
so my
Celsius.
temperature. Celsius, again, you gotta convert it to Kelvin.
Yep, so we're going to
So
add.
do 273 plus 20, and just in case you can't do simple math, we got a calculator.
293.
Kill.
I can do simple math.
I can't.
Okay, so again, my PV equals nRT, and I need to get my R value.
And remember, it's got to match your pressure units.
Mm-hmm.
So we're going to flip to our reference page.
MMHGs, all right. So MMHG is going to be this one over here at 62.4. And now I can plug and chug.
All right.
So 720.
Times your V, is that your unknown?
I don't know what it is. So okay. And then N is 2. R is 62.4. And T is 293. So, well, this one's 2 times 62.4 times 293 is...
All right. Can you do that one mentally?
That is... No, I can't do that one mentally.
I can. Wait, I got 36,566.4.
Okay, and that's my...
You can call me Rain Man.
All right.
I'll call you
Rest
Nighthawk.
Man, get it? Okay, so 720. So I need to get rid of the 720, so V's by itself. So let's divide by 720. Divide by 720. And my V is equal to
50.79. Because we're going to round to the second decimal place of the
it's
hundredths.
volumes, therefore it must be in
Liters. That was too bad.
really not. Okay. Next.
All right, so it says what temperature in Celsius. So we know we got to find temperature.
We gotta find temperature.
And
And
it says
uh-oh.
5 grams?
Yeah, let's change that to moles.
No, it says grams.
I know, but we're gonna leave that.
No, let's change it to
Let's
moles.
change it.
So,
We're
sorry,
gonna be nice.
Art.
And change that to moles. That's all good.
Okay.
So that's gonna be my N. We're not gonna make y'all convert grams to moles. We're gonna be nice to y'all. Okay, so that's 5 moles. And it's going
A
to
pressure of
see, that one even tells you it's a pressure.
900 millimeters of mercury.
MMHG at a volume of
750 milliliters.
okay, that one I do have to change because that needs to be liters.
Okay.
So I know that there's 1,000 milliliters per liter. So basically I need to divide by 1,000, which is going to give me 0.75 liters.
Dang, you're good at this. So really, it's like I'm just moving my decimal 3 places to the left.
Pretty much. Okay, so I need my R value. We're doing MMHG again.
So that would just be the 62.4.
Because we already looked that up, but you can look it up again if you need to. No harm, no foul. Okay, so PV equals nRT. I like to rewrite my equation every time so we don't get it wrong.
Nice reminder to follow it too.
Yes.
So you know exactly what order to plug into.
So 900 times 0.75 equals
N is 5.
5. And then,
R is 62.4.
and then I need my T. So
All right, so first we want to simplify each side, so we're going to multiply the
900
left side.
times 0.75.
All right, and I got 675.
75.
And then other side I'm going to do 5 times 62.4, which would be 312.
T. So
I want to get T by itself, so if I'm multiplying by 312, I've got to divide by 312. So I'm going to do 675 divided by 312, and I get 2.16. And that sounds cold, but that's in Kelvin.
Is in kelvins.
And
So that's my temperature. But that's not asking me for kelvins, it was asking me for Celsius.
Okay.
So what do I have to do? Well, let's see. Ooh.
Okay.
So, oh man.
I'm subtracting 273 to get to Kelvin, so for this one I would need to add, right?
Wait. No, I added 273 to get to Kelvin, so I need to subtract it to get back to Celsius, right?
Yes. God, you're so smart. So we're going to do minus 273.
Negative 270, and yes, that happens.
Ooh, that's cold.
0.8 degrees Celsius equals your temperature. Yes, that is very cold. That is, in fact, almost absolute zero.
Crazy.
Yes.
All right.
All right, that's it.
So, you have any questions?
No.
Ask.
Go away.
You're good. All right. Bye.